Hello guys and welcome back in this lecture. Now we're going to talk about how to choose our main electrical panel circuit breaker and how to choose its cabling. So usually the main circuit breaker is here to protect our cables between the distribution panel and our electrical panel. A distribution panel is the panel that is connected to the grid and it's giving power to your control panel. Usually this one comes pre-designed from other power companies that are specialized in designing these. And you need to extend the cables, the power cables from this panel to your panel. Now, the main circuit breaker, main functionality is to protect this cable from being burned, because the distance here will affect a lot the performance of here. So if the distance increases, the voltage drop will increase. Hence, if your voltage drop increased a lot, the cable diameters may not hold this change. So what you should do is increase the diameter if the distance between these two panels increased. I know the main circuit breaker, usually it's said that you should design it for your electrical panel. That's correct. You should take into your consideration your total current consumption. But also you need to take account for the cable distance. So what are the steps that we should follow in order to do this? In order to calculate the cable diameter and the main circuit breaker rating. First, you need to check your total panel current consumption. Let's assume that our current consumption is 25 amps. We'll measure the distance between the two panels. Let's say it is 300 meters. Now I know this is too much, and usually this is not the case, but I will show you how the distance will affect a lot the choice of cable diameter. Next, you need to check your power factor for your electrical panel. If you don't know that, and there is no way you can calculate it, well, what you can do is assume the worst case scenario. Assume that you have the best power factor of 0.95. Now, fourth step is going to be checking your cable impedance per meter. Now, every cable should have in its data sheet what is its impedance per meter. If you don't have this information, I will show you a table later that contains the cable diameter and what is its impedance at certain power factor. This impedance will change depending on the diameter and depending on the power factor of your electrical panel. So let's assume that we chose 1.5 millimeters cable, and where the impedance here is 0.013 according to the table I will show you. We'll assume that it is the worst case scenario, or actually the best case scenario since the power factor is high, 0.95. And next you need to know what's your operation voltage. Well, I'll assume that it is 380 volt AC. Now, we assumed that our current consumption of our electrical panel is 25 amps. Take a look at this table here. It contains the diameter of the cable and the maximum current that it can handle. So for 1 millimeter, it can maximum take 20 amps. For 2.5, it can take a maximum of 34. So as I said, we're trying to protect the cable from the maximum current, right? So our electrical panel is consuming 25 amps, and 25 amps here corresponds to 1.5 millimeters. So 1.5 millimeters should be initially suitable for our electrical panel, right? Because 1.5 can handle 25 amps. Now, we need to check what is the percentage of voltage drop here. We will apply this formula, and the percentage shouldn't exceed 3%. If it exceeds 3%, then we need to increase the diameter. Let's take a look. So what is this formula? 1.373 times the current. The current is the total current of your electrical panel. In our case, it's 25. The length, in our case, is 300 meters times 100 times cable impedance per ohm meter. And as I said, according to that table, it's 0.013. We'll take a look at that table in a second. And the operation voltage here is actually 380 volts. If we apply this, we'll get 44% voltage drop. That's way more than 3%. So for this distance, it's impossible to use that. Because the current will be too high, the cable will get too heated, it will burn out. So we need to increase the diameter. Take a look at this table here. This is the table I'm talking about. It has the cable diameters, and here it has the impedance ohm per kilometers. Well, if you wanted in meters, we just divide these numbers by 1,000. That's it. So we are using this area here at cosine Q or phi equals 0.95. As you saw, we used 0.0138. This is it. Because it's per meter, we divided it by 1,000 and we got this. Now, here we're saying that let's use 6 millimeters cable. 6 millimeters is actually 0.0347. This is 0.00347. Okay, if we apply it, we'll get 11%. Still, it's too high. We need to drop it to 3%. So let's increase the cable diameter further. Let's choose now 25 millimeter cable. And 25 millimeter, if we take a look here, it has 0.847. So it is 0.000847 ohm per meter. If we apply it, we get 2.89. So it is acceptable because it's less than 3%. So now we have agreed that we need 25 millimeters cable. But remember, we're trying to protect this cable. So we need a circuit breaker that should trip at the maximum current this 25 millimeters cable can take. A 25 millimeter cable, take a look at this table now, it can maximum take 137. So we should choose a circuit breaker of 137 amps tripping characteristic. It should trip at this current. Whenever this current is exceeded, we need to drop immediately the circuit breaker within a few seconds or a few 10 seconds before the cables got too heated up. So this is how it shows it now. For this distance, 300 meters, we need 25 millimeters cable and 137 amps main circuit breaker. This is how we choose the cable and the main circuit breaker, guys, for any electrical panel. See you in the next tutorial.